Hello everyone, and today we are going to show how to do advanced machining in CATIA. So now first we select mechanism design and part design, and then rename the part name to anything that you like. For us, we write it as a mouse, and then we pick XY plane and press sketch. So start it with spline with coordinate x0 and y0, and then x45 and y is 9, x90 and y0. And after that we click on the spline that we draw and make point 1 and point 3 tangent C. After that we draw line of axis, which is 30 mm, and then we draw line at point 1 and point 3 coincidence to the line of axis, and then after that we make a corner at the line where this one is radius 15, and then one more in front with radius 10. After we done that, and we drag all, and then we mirror, and then this is the final draw as it workbench, and then go to shape, generative shape design, and then pick extrude and click on the drawing, and we will extrude it with 30 mm. After that we click on X plane and press sketch, and then we are going to make the upper layer of the mouse. We started with 15 for X, 0 for X and 15 for Y, and then negative 50 for X, and the maximum height is 30 for Y. And then for the last point, negative 90 for X and 20 for Y. After we done that, we make the same step again. Click on the spline and make point 1 and point 3 tangent, and then right click on point 1, make it horizontal to the line, and point 3 horizontal to the line. After that we exit workbench, and then we extrude it with 60 mm. After that click shape fillet and click support 1 for the first drawing and support 2 for the second drawing. Change the direction or the fillet definition, and then make radius of 10, and then you will get this shape. This is your final shape of the mouse. After that we are going to save the part that we draw. And then we insert the new body to the drawing. which is called body 2. So body 2 is used for stock that we can use in advanced machining. So we pick XY plane and sketch the rectangle shape of the stock. We constrain the box with a shape with 10 mm difference. The size of the box may vary depending which you prefer. After that, we pad the body that we draw with 50 mm, and then we right click and click properties, change the color and the transparency so that we can see the part that we are going to use in machining. And this is the result. After that, hit the save button, and then we are done. So next we are going to machining, which is advanced machining. In advanced machining, first step is click part operation, then click machining. Make sure that it is 3-axis machine, and then click default reference machining, and this is where you need to define which point that the process will start. So click on the point, the middle one, select the position, and then click on any edge that you want. After you click it, OK, click OK, and then we are going to decide which part is going to be the design part and the stock part. So the design part will be the part body that you want, so double click, and then for stock is the red box that we have drawn. After you've done that, click OK, and then we are going to change the tool, click and mill. After we done, make the tool change, then click on the tool change, and then click operation that we are going to operate, which is roughing. So this is the option that we get from roughing icon, and then we click part. The part is the shape that you want, so click part body. Rough stock is the red box, click it, and then the safety plane is the top of the box. Click the left tab, which is the strategy shorthand. This will give you tooth path style, change it to zigzag, and machining tolerance to 0.01, and then you click on the icon below where it is tooth path replay. And after that, you can see the full video of the process. So this is how your product is being machined. Then click OK. After that, click insert, and then we change the tool again with specific dimension of the tool that you are going to use. And then we are going to make a profile contouring, so click on the icon and then hide the body tool, which is the stock. Click on the region and then click navigate on both of edges, and then for the bottom part we click on XY plane. And then click OK, and then we are going to review how this is work. So click play and you see the result for your product. As you can see now, the blue surface is smooth. It is because of the profile contouring. After that, change the tool again using end mill with specified dimension that you want. After that, we are going to use sweep roughing. So we click the part as part body, and then the safety plane is the top region of the red box. And then to path computation, and we can see the process that happened to the machine. So we click full video. And then after that, we change the tool again. This is for finishing. Still we using end mill and specific dimension of the tool. After that, we click on the sweeping. Then define the safety plane and the tool and the part, and then we compute. For that, we click on the strategy tab and change the scallop height to 0.1. This is for the finishing, so the smaller scallop height the better the surface. As you can see now, the green is having a smaller gap between each of the line, so it means that the surface will be smooth. As you can see now, the surface on the top of the part is look like smooth, but we still have the surface is still not smooth enough, so we are going to insert a new tool with smaller diameter so that the surface of the part will be more smooth, because we are going to change the scallop height to 0.01. As you can see now, our product looks more smooth rather than the previous one. After you have decided all the process that you are going to make and you satisfied with it, so we are going to save it in NC code. So click tool and option, so post and processor and controller emulator folder, and make sure the extension is cat NC code. Click OK, and then click part operation, click machine and numerical control. So choose the part, the processor and NC data type that you want. This one you may ask your lecturer. and then click manufacturing process and generate NC code interactively. After that, make sure that the resulting NC data is in NC code, and for the output file you may locate which folder that you want so that the code will be saved into the folder. After you satisfied with of the option and the output file, click execute. And then enter code file, and then we are done. Okay, so open the file that open the folder that you save for the output file, and then you can see there are 6 files, so you can preview each one. So this is the NC code that are generated to the notepad. You can see all the data of the machining process will be stated on this notepad, and then there you go, we are now finished. So thank you.